Hello, my name is Kevin Nguyen, and this is Lab 4, Circuits and Capacitor. So the purpose of the lab, we'll be predicting the behavior of series and RC circuits based on varying resistors. We'll use tools such as the voltmeters and ammeters to measure the values of conventional current and potential differences. And then we'll examine the behavior of ohmic resistors and capacitors. So equations that I use would be V equals I times R, the loop rule, where the total potential differences around the whole loop is equal to 0. The node rule where in equals out for the current, and then R times C is equal to seconds. So for the series circuit, I predict, so this first we set it up a circuit with 2 resistors and 2 batteries. And the battery total voltage is 3. And then, so for my prediction, we assume that I assume R1 will be negative 0.96 voltage, R2 will be negative 2.04 voltage, and then there will be 0 voltage throughout the wires. And this also makes sense because the battery is positive 3 voltage, so the resistors has to be negative 3 for the total sum to be 0 according to our loop rule. And then reversing the connection and the amp meters will still give you the same results, so it wouldn't matter. And then I remove the amp meter and replace it with a voltmeter instead. So now there's a gap, so there will be no current flow in between. And so that would make us have a 0 volts at both resistors. And the gap is negative 3 because it cancels with our battery plus 3 voltage. And it is negative because it's moving in the opposite direction of our electron current, and this is the conventional current direction. And then this is me finding the voltage at each section. So it's going to be negative 0.96 at resistance 1, negative 2.04 volts at resistance 2, and our battery is positive 3, which was correct with our predictions. And this is my graph of potential differences versus position. So A is where our battery is, 3 voltage. So this is battery 1, then battery 2, total of 3. And then it goes from B, the wire, which has 0 resistance. So it'll be constant, and then it goes down because our first resistor by negative 0.96. Then another wire is constant again, and then another resistor which make it negative 2.04 volts. And then our second part of the lab where we created an RC circuit. So when first we charged up our capacitor, and when it is charging up, the current is moving to the capacitor and the capacitor gains charge. Then we take out the battery, and now the capacitor is discharging, and current is leaving the capacitor into the light bulb, and the capacitor loses charge. Then I did some experiment on charging and discharging based on the resistance. So it took us 6.4 seconds to charge up the capacitor of 10 ohms and 6.4 seconds to discharge. It took us 12 seconds to charge up capacitor with 20 ohms and the same to discharge. And this makes sense since the resistance is 2 times as much and V is equal to I times R. Then I did another experiment to find RC, the time constant of the circuit. I did this by setting it up with our 9 volts battery, 0.2 farad capacitor, and a 30 ohms resistor. And I timed it with a stopwatch and measured its voltage as it discharges within 20 seconds. And this is the result. So I plotted a time versus natural log of delta V over delta V initial, which would be 9. And we get this linear negative slope plot. And we know the slope is negative 1 over RC. And from our plot, the slope was negative 0.1662. So negative 1 over negative 0.1662. Our RC is going to be 6 seconds. And this is very close to our expected value of R times C equals seconds. So it's 30 ohms times 0.2 farads, which is equal to 6 seconds. Now, what if questions? So what if we use a real ammeter instead of ideal? From the model, there would be resistance in the ammeter in real life, which will cause our current to be lower. And what if we use a real battery with no resistors to charge the capacitor? The model would predict that it will charge the capacitor fully immediately. However, in real life, the batteries have resistance of their own, and this will slow down the process. Batteries will also drain in real life, so there will be less current going out as time continues. And that's the lab. Thank you.